Now let us solve example problem 3.1. So the figure illustrates an elastic head-on collision between two balls. One ball has a mass of 0.25 kilograms and an initial velocity of 5 meters per second. The other has a mass of 0.8 kilograms and is initially at rest. No external forces act on the balls. What are the velocities of the balls after the collision? So, before collision, we have this figure. Um, the larger ball is initially at rest and the smaller one is moving to the right with a velocity of 5 meters per second. And after collision, both balls will have a final velocity, but they are different. So we will denote that the final velocity of the larger ball as v sub f2 and the final velocity of the smaller ball is v sub f1. So notice that we have two unknowns here. So therefore, we have to generate two equations to find the two unknowns. So first, we will be using the conservation of linear momentum to generate an equation. And since it is stated in the problem that it is an elastic head-on collision, therefore the kinetic energy is conserved. The initial kinetic energy is equal to the final kinetic energy. So now let us write down the first equation. So I will write that this is from the linear momentum, or the conservation of linear momentum to be exact. So we have the mass times the velocity initials. So 0.25 kilograms times the initial velocity, which is positive 5 meters per second, plus so the the initial velocity is equal to 0, but I will still write it down. So 0.8 kilograms times 0 meters per second. This is equal to the final momentum. So we have 0.25 times v sub f1 plus, okay, so again, I forgot to establish the sign convention. So again, to the left is negative and to the right is positive. So since we assumed that the final velocity of the smaller ball is to the left, this is negative. And as for the larger one, this is equal to 0.8 kilograms times the final velocity v sub f2. So simplifying, we have 1.25 kilogram meter per second. This is equal to negative 0.25 v sub f1 plus 0.8 v sub f2. So we have equation 1. As for the conservation of kinetic energy, we can generate another equation. So again, kinetic energy is equal to 1/2 times the mass times the square of the velocity. So this will be 1/2 times 0.25 Let me just erase that one. 0.25 kilograms times the square of the velocity, 5 meters per second squared, plus 0. So we can simplify. And as for the final, we have again 1/2 times mass, 0.25 kilograms, times the square of the velocity. This is v sub f1 since it is final. So v sub f1 squared plus, so for clarifications, again, v sub f1 should be negative since we assume that it is going to the left. So negative v sub f1. So but we will square this one, so the negative sign will be cancelled. Anyway, so again, for the final velocity, we have v sub f2. The final kinetic energy, we have 1/2 times the 0.8 kilograms times the v sub f2 squared. So solving simultaneously, we can find that v sub f1 is equal to 2.6190 meters per second, and v sub f2 is equal to 2.3809 meters per second. So both answers we yielded positive and positive. So that means that our assumptions for the final velocities are correct.